Let's go ahead and talk about this one together. How many vectors are we adding together here? 2. All right. We have the force for the plane and the force due to the wind, right? We want those to add together to be due north, right? We want it to fly straight to its destination. So the x component of my resultant should be 0. Are you good with that? What else can I fill in? What else do I know? It is, yeah. We're doing all velocities right now, though. I guess these are velocities. So let's not worry about the distance yet. I think that's going to be on number 5. The velocity of the wind we know, right? It's due west at 25 kilometers per hour. Therefore, what? What do I know next? The x component for the plane needs to be positive 0.5. And I know that the plane itself is moving at 175 kilometers per hour, right? So if we're looking at the angle the plane is flying, right, we know it's going to be something to the east of north. We know that the x component is 25. Where's the 175 go? The hypotenuse, yeah, why the hypotenuse? Yeah, it's flying at 175 kilometers per hour. Does that make sense? Now we can find our angle, sine, cosine, or tangent. Sine. Calculator should be. Inverse sine of 25 over. Or 25 over 175. Yeah. Hey, I think you might have got lucky if you put 175 on the start. Just because that 25 comparatively so much smaller. Okay, yeah. I did it. Yeah, if you put 175 in the vertical direction, in this case, it wound up being the same thing. If those numbers were a little different, it wouldn't necessarily. It's fine for now. Same problem, different question. So now the plane is flying due north at 175 kilometers per hour. We want to know how far off course would the plane be after it travels 1750 kilometers. C is correct, what? Good. It's flying, the only northward velocity is due to the plane's engines at 175 kilometers per hour. So to get to 1,750 kilometers, it's going to take 10 hours. The only thing moving it left to right is the wind. If it's being blown west 25 kilometers per hour for 10 hours, it's going to be way off course C, 250 kilometers. Questions on that? And finally, number 6. Without the angle that we found in question 4, so it's, again, trying to fly due north, we want to know what is the magnitude of the velocity vector. So it's trying to fly north at 175 kilometers per hour. It's being blown to the west at 25 kilometers per hour. How fast is it? Because there are only 2 vectors and one's north and one's west, we don't technically write out the X hat, Y hat notation. There's actually only one answer that makes sense. This one. Yeah. We're trying to go 175 north. We're being blown west at 125. The hypotenuse is going to be bigger than either one of those sides, right? We're looking for the magnitude of the velocity vector. So the resultant, when I combine those two vectors, they're going to add to 1. The 175 before was the hypotenuse. Because we knew the x component, this was the total speed of the plane, just the plane without the wind, was 175. Would be that. We didn't know the one. Now, since it's due north, that 175, instead of being this way, it's just basically turned up here. And instead of finding like the x and y component of the plane, now we were looking for the x and y component of the plane. Any other questions on those three? Number 2, we are going to be looking at contact forces, in particular, normal frictional force. We will analyze incline problems that deal with those forces. We are not going to get to objective form. All right, so first of all, Newton's law of universal gravitation. What is fate? Everything has gravity pulling against them. Yeah, kind of everything does. Any two objects that have mass are going to exert forces on one another. All right. So any two objects exert gravitational forces on each other that are proportional to what? Proportional to, the two forces will be equal to each other, yes. It's going to be proportional to the masses. All right, so if I double one of the masses, that would double the force. If I multiply one of the masses by a quantity of 4, the force would increase by a factor of 4. What's inversely proportional? We'll do that now for 2. An inverse proportion. You guys know what that is? Yeah, so when one doubles, the other one breaks in half, right? What would it be inversely proportional to? The distance apart goes, except it's the square of the distance apart. All right. So when I double the distance between them, so doubling, I multiply it by a factor of 2. 2 squared is 4. So the gravitational force will decrease by a factor of 1/4. What if I triple the distance between them? What factor would the gravitational force increase or decrease by? Decrease by 1/9, right? Does that make sense? All right, the square of the distance between them. Therefore, the equation is going to be f sub g is equal to big G times n1 times n2 divided by r squared. You guys see that formula last year? I don't know. Go ahead and get your equation sheets out, both of them, the green one and the blue one. What do M1 and M2 stand for? Mass 1 and Mass 2. Mass of object 1 and mass of object 2. What about R? What do you think R stands for? Distance between the centers. What about big G? Gravity. It's not gravity in 9.8. It's not acceleration due to gravity. No. No, that would be an electric force. That wouldn't even be necessarily a gravitational force, although there is a gravitational force between the electrons. It's a constant, all right? Capital G is the constant for gravitation. Constants can be found where? The green sheet. All the constants are on the green sheet. Everybody find the universal gravitational constant. You should see it there, 6.67 times 10 to the negative 11 cubic meters per kilogram second squared. All right, green sheet, do we always get used that one or only sometimes? Always. You always get that table of information. So that's not something you need to memorize. Since we are going to be dealing with some problems, it might not be a bad idea on your graphing calculator to store 6.67 times 10 to the negative 11 as G. And that way you don't have to type it in all the time. You can just type in G unless you reset the memory or your battery completely die on. The negative sign simply indicates direction. I think the best way to think about direction is we have two objects. Gravity is an attractive force or a repulsive force. Attractive. So if I have two objects, if I'm looking at this object right here, and we're talking about the direction would be this way. If we're talking about the other one, it would be in the negative x direction. So instead of like including the negative sign, I think it's easier to think about direction in looking at maybe a physical drawing of it and figure out if it's up, down, left, right. So really the negative sign is indicating that it's their force one another. That's all that's good. So example 5, again this problem is on your handout, so you don't need to copy the problem down. I want to get that out and then in your notes, write example 5 for all the work for example 5. And you have a problem to refer back to. It says, George, who has a mass of 77 kilograms, jumps off the diving board 3 meters above the surface of the Earth. We want to know the gravitational force between the Earth and George. We're given the Earth's mass, we're given the radius of the Earth. And let's use Newton's universal law of gravitation, the formula that we just did to find it. So F sub G, any problems that we're doing, the first thing you always need to do for the AP test, and thus for my class as well, is write down the formula you're using. Don't start out by plugging everything in, because if you made a mistake in plugging stuff in, you'll get kind of counted off double. Once for plugging it in wrong, and now since you plugged it in wrong, you're not getting the point for the formula. If you show the formula, and then step 2, show where you're plugging stuff in, now even if you make a mistake in plugging stuff in, you're going to get the formula. Does that make sense? All right, as we look at AP problems, that hopefully will make for as we go. So always write down the formula you're using first. Now we can plug stuff in. The Earth's going to win? Yeah, the Earth usually wins. We're talking about objects that on the Earth. The sun totally wins. For some reason, people forget to square the distance. Should be r squared. Really, technically, George's distance is going to be 6.37 times 10 to the 6 plus 3. So he's 3 meters above that, right? That plus 3 is not going to change to 6.37 times 10 to the 6. That's fine, yeah. Now, if they're adding something that's times 10 to the 5th,